In this lesson, we're going to explore complex numbers. So what we'll do is we'll understand the difference between imaginary and complex numbers. Then we're going to simplify complex numbers and perform operations with them. And then we're going to solve quadratic equations involving complex numbers. So the first thing that we have to make sure that we understand is what an imaginary number is. So if we had an equation like x squared equals -1, and we wanted to solve for x, what we would need to do is we would need to take the square root of each side. But here is where we have an issue. So if I take the square root, x is equal to plus or minus the square root of -1. We can't take the square root of a negative number. So remember that if you have a number underneath the radical and you're trying to simplify it, you're looking for what number times itself is going to give you the number under the radical. And we take any numbers and try to multiply it by itself, we're never going to get a negative number. So if I had a number like, let's just say 2 times 2, right, that's going to give me 4. If I have -2 times -2, that's also going to give me 4. So there's no way that we can multiply the same number and get a negative number. So we bring in these imaginary numbers. So whenever we have the square root of a negative number, we say that the square root of -1 is equal to I, which stands for imaginary number. If I were to square this, so square this side and square this side, I end up with I squared, and then the square root and the square will cancel each other out, and we end up with the -1. So these are both very important things that we need to remember. Okay, so you might be asking yourself, why imaginary numbers? They're not even real. This makes no sense. So actually, it's really common for equations to be unsolvable in one number system, but solvable in another. Okay, so the first number system that you learned were counting numbers. So those are numbers that you use to count. 1, 2, 3, 4, and so on. So if you only know positive numbers that start with 1, you can't solve x plus 8 equals 1. In order to solve x plus 8 equals 1, you need to know integers. So integers are the negative numbers and the positive numbers. Right? So if you only know integers, then you can't solve 3x minus 1 equals 0 because you would get a fraction as an answer. So you need to know rational numbers. If you have x squared equals 2 and you take the square root and you get that x is equal to plus or minus the square root of 2, you can't solve that unless you know about irrational numbers. If I have x squared equals -1, like our previous example, you can't solve that unless you know about imaginary numbers. So there are these other number systems that we'll come across, and as you continue to study math, you're going to see the importance of these numbers in the future. Even if they seem kind of ridiculous at this moment, they come into play a little bit later on. So now we want to simplify the following square roots. So first off, we want to have the square root of -7. Whenever we see a negative underneath our radical, we can think of this as being the square root of 1 times the square root of 7 in this case. Whenever we have the negative, that's the square root of -1, which represents our imaginary number, which is I. So we pull out the I and bring it outside, and then here we have the square root of 7 left over. So this 7 can't be broken down, so we would just leave our answer as I square root of 7. For number 2 here, we have the square root of -36. So again, you can break it down into the square root of -1 times the square root of 36. So the square root of -1 is I, that comes outside. The square root of 36 is 6, so that's going to join the I outside. So we put our number in front of the I. So this would be 6I. Okay, and then for number 3, the square root of -12, we have the square root of -1 times the square root of 12. Okay, you don't need to write it this way as long as you know that you're taking out the I. So you could skip this step and just go right to like I square root of 12. The 12 can be broken down because there's a perfect square within 12, which is 4. So if I break this, I'm just going to keep writing it so we see where we're getting it from. So this is the square root of 4 times the square root of 3. So from the square root of 4, that 2 comes out. From the square root of 1, the I comes out. And then that 3 is still under the radical, and that's left over. So we have 2I square root of 3. So complex numbers are when we have a combination of a real number and an imaginary number. So the real part goes first, the imaginary part goes second. The imaginary part is the one that is connected to the I. So we can perform operations with complex numbers by looking at the real parts and the imaginary parts. So the first thing we're going to look at is adding and subtracting. So we're just going to combine like terms. So like terms are going to be the real parts and then the imaginary parts. So for this first example, we have 7 and -3 that are like terms. Those are our real parts. We have -2i and we have +i that are our other like terms. Those are our imaginary parts. So we're just going to combine like terms. So 7 plus -3 is going to give me 4. -2i plus I is going to give me -i. Okay, in this second example over here, we're going to do the same thing. So we're going to look at our real parts, so -3 and 3. So if I add -3 plus 3, that's going to be 0. So they're going to cancel out. And then I have 9i plus 9i. So that's going to give me 18i. Okay, and this third one, now we're doing subtraction. So with subtraction, you want to be careful. Okay, you can do one of two things. You can change it to addition, but if you're going to change it to addition, you need to change the signs in the term that's next to it. So for instance, if I wanted to rewrite this, I could make this a plus sign, but then I have to make this a -8, and I have to make this a +6i. Okay, so if you'd rather do addition, just make sure you change the sign of the second one. If you don't, you just have to make sure that you remember to distribute the negative. So the negative has to be applied to the 8 and to the -6i. Okay, so we'll do this first example by changing it to addition because I already did that. So now we're just going to do the same thing we did before. Our like terms, okay, we have 8 and we have -8. So again, that's going to cancel out. And then we have 6i plus 6i. So that's going to give us 12i. Okay, and then this last one, I'm going to keep it as subtraction. So I have 1 and 3, but I'm distributing the negative. So I have 1 minus 3, which is going to give me -2. And then I have 5i minus a -2i. So that becomes plus, and I get 7i. Okay, the next thing we're going to look at is how we can multiply complex numbers. So we're going to distribute or FOIL like we normally would. The thing that we need to remember here is that I times I is -1, right? So anytime that we get I squared in our problem, we must replace that with a -1. So in our final answers, it's okay to have I, but we do not want to have I squared. We want to replace that with -1. So when I look at this first example, 7i times 3i, so I'm going to multiply 7 times 3, so I get 21. I times I is I squared. Okay, we can't have I squared in our answer, so we replace I squared with -1, so we get -21. Okay, and the second one, we have to FOIL. So notice that there's nothing in between these parentheses. In the previous example, when we had subtraction, we had the subtraction sign or we had the addition sign. When there's no sign in the middle, you're doing multiplication. So we're doing 2 times 4. We're going to FOIL this out. So we get 8. We're going to do 2 times 5i. So that's going to give us 10i. We have -3i times 4. So that's -12i. And then we have -3i times 5i, which is going to be -15i squared. Okay, so now we can combine our like terms. So this 10i and this -12i. So we're going to get 8 minus 2i. And then we have -15, but we're going to change I squared and we're going to replace that with -1. So now we have 8 minus 2i plus 15. And then again, we're going to combine our like terms. So we have 8 and 15. So we're going to end up getting 23 minus 2i. Okay, and then for this last one, again, we're going to FOIL. So -4 times -4 is going to give us 16. -4 times -5i will give us 20i. 5i times -4 is going to give us -20i. And then 5i times -5i gives us -25i squared. So the 20i and the -20i, they're going to cancel out and become 0. So we have 16 minus 25. But we have to replace I squared with negative 1. So we end up getting 16 plus 25, which is 41. The last operation that we're going to look at is dividing complex numbers. And there's two different types that you're going to see. So if there's one term in the bottom, so like this first example we're going to go over, then all you need to do is multiply the top and bottom by I. So we're trying to rationalize, and you might have seen this with radicals in the past. So rationalizing means we need to get rid of something in the bottom. So we want to make sure that we don't have any i's in our denominators. So with one term on the bottom, we're going to multiply by I. If there are two terms in the bottom, like in this second example, we have to multiply the top and bottom by the complex conjugate. So we're going to come back to what that means when we actually do that problem. So let's just worry about the first one right now. So I have 4 minus I over 6I. So since I only have one term in the bottom, I'm going to multiply the top and bottom by I. So when I multiply by I over I, I'm really multiplying by 1, so I'm not changing this problem at all. So what I'm going to do is distribute this I to the top. So I'm going to do 4 times I, so I get 4I, and then I'm going to do negative I times I, so I get negative I squared. Okay, on the bottom, I have 6I times I, so that's going to give me 6I squared. We have our I squareds, but we need to replace those. So I have this 4I, and I'm going to subtract I squared, so that's going to become negative 1. On the bottom, I'm going to do 6 times instead of I squared, replace that with negative 1. So we end up getting 4I plus 1, because we have that minus a negative, and on the bottom, we have negative 6. Okay, so technically this is correct. You could leave that as your answer, but most of the time you're going to see the real part first and the imaginary part second. So I'm going to just flip-flop my top. So I'm going to do 1 first plus 4I over negative 6. So I'm just putting the real part first, the imaginary part second. So you could leave this as your answer. Okay, if you don't want to have the 6 in the bottom be negative, you can just distribute it to the top instead. So I could flip this. So I'm just going to put or here. Or if you wanted to, you could make this negative 1 minus 4I over positive 6. Okay, so either one is correct. It's just a matter of, do you want the negative on the bottom or on the top? So either one is correct. So for this second example, we have 2 terms in the bottom. So these 2 terms, we have to get rid of the I in the bottom. But because we have those 2 terms, we need to use this thing called the complex conjugate. Okay, that's just a really fancy math term for take whatever's in the bottom and change the sign in the middle. Okay, so if the bottom is 3 plus 4I, I'm going to multiply the top and bottom by 3 minus 4I. And then 3 minus 4I. So again, similar to what we did in the first one, we're multiplying technically by 1 since the top and bottom are the same. Okay, but there's 2 terms, so we're going to use that complex conjugate. So the first term is going to stay exactly the same. That second term, we're just going to do the opposite sign. So it was plus, now it becomes minus. Okay, so once we have this set up, we're going to just FOIL the top and FOIL the bottom. So on the top, we have 5 times 3. So we get 15. We have 5 times negative 4I. So we have negative 20I. We have negative 2I times 3. So we get negative 6I. And then we have negative 2I times negative 4I. So that becomes positive 8I squared. And then on the bottom, we get 3 times 3. Let me just show that. 3 times 3, so we get 9. Then we get 3 times negative 4I, so we get negative 12I. And then we get 4I times 3, so that's positive 12I. And then 4I times negative 4I gives me negative 16I squared. So the whole point of multiplying by this conjugate is to get rid of the I term. So in the first example, when we just multiplied by I, the only thing we had in the bottom was I squared that we could replace with negative 1. But here in the bottom, if I didn't change the sign, I would still have a plain old I term in the bottom. So by multiplying by the conjugate, what we end up doing is we get a positive and negative version of the I term, which will cancel out. and then we're just left with our I squared, and then we can replace that with -1. Okay, so let's just clean this up a little bit. So in the top, we have this -20i and this -6i. So I'm going to get -26i. And then I have 8i squared, and I'm going to replace I squared with -1. Okay, on the bottom, we have that 9 minus 16. Instead of I squared, replace that with -1. So now I have the 15. Well, I'll just rewrite this. 15 minus 26i minus 8 over 9 plus 16. So we can combine like terms. So 15 minus 8, we're going to get 7 minus 26i over 9 plus 16 is 25. Okay, so at this point, so on both examples, if anything could be reduced, I would reduce it. But remember, in order to reduce something, all 3 must be divisible by that number. So if everything was divisible by, I don't know, 2, you could divide everything by 2 to simplify it. But in these cases, it wasn't, so we left it alone. So then the last thing that we're going to look at is solving quadratic equations. So these are just a refresher of what we've done before. But now, if we get a negative under the square root, we know how to handle this. Okay, so if I ask you to solve a quadratic equation, unless it says specifically which way to do it, you can choose to solve it however you would like. So if it can be factored, by all means factor. If you like completing the square, you can use that. If you want to use the quadratic formula, you can use that. So I'm just showing 2 examples, one of each type. Okay, but if you wanted to, if it just said to solve, this first example you could use quadratic formula for as well. So for completing the square, just to review that a little bit, we want to get the c term on the other side. So we're going to make this x squared plus 4x. I'm going to leave that space, and then I have minus 6. Okay, so then I'm going to check my a term. Okay, a is 1, so I don't need to take anything out. I'm going to take my 4, divide by 2, so I get 2. I'm going to square it, so I get 4. So I'm going to add 4 here, and I'm going to add 4 here. So on the left side, we have x plus 2 squared. On the right-hand side, we have -2. So now when I go to take the square root that side, square root that side with the plus or minus, the square and square root will cancel out. So I have x plus 2 equals, and then the square root of -2, because it's a negative inside, I know I need to pull out the I, and then it becomes positive 2 on the inside. And that can't be broken down at all, so we just leave that there. And then we're going to move this 2 to the other side, so we'll subtract 2, and we end up with x is equal to -2 plus or minus I square root of 2. Okay, so when we're solving quadratic equations and we have imaginary numbers, what this means is that the graph is not crossing the x-axis. So when we normally solve a quadratic and we get, let's say, x equals 1 and x equals 2, that's where your graph would be crossing the x-axis. So if it was x equals 1, oh, well, whatever. If it's crossing the x-axis twice, it looks like that. But in a case like this, where we set our equation to 0 and we're solving for those x-intercepts, when they're imaginary, it doesn't have any. So that's where you have no solutions. So it's something like this, where it's kind of free floating and it's not touching the x-axis. Okay, and example number 2, we're using the quadratic formula. So remember our quadratic formula, we can identify our a, b, and c. So a is 3, b is going to be -7, and c is going to be 5. So when I plug it into my quadratic formula, I have -b, so that becomes +7, plus or minus the square root of b squared, so -7 squared, minus 4 times a times c, all over 2 times a. So I end up with 7 plus or minus the square root. This would be 49 minus 60 over 6. So if I simplify the inside, I'm going to get 7 plus or minus the square root of -11 over 6. And I have to simplify this a little bit because I have the negative under the radical. So I'm going to pull out the I, and this is now going to become positive 11 inside, all over 6. Okay, and I can't break down 11 at all, so this would be our final answer. And again, if anything could be simplified, you would simplify. You never want to divide out anything that's in the radical. So if let's say these all were divisible, you're looking at this number in front, what's attached to the I, and what's in the bottom. And those are the only things that could be divided out. Okay, so for homework, you're going to try these 6 problems. So you're going to have practice with the different types of operations with complex numbers, and then you're going to solve these quadratics. Note that it does not tell you how to solve them, so you can use quadratic formula or completing the square, whichever you prefer.